So the diagram has order 4 rotational symmetry, and this has some consequences. For example, ABD must be a 90-degree isosceles triangle, okay, because AFD will be the same for it to have rotational symmetry. So that angle there will be 45, and the angle ABD will be 45. Now, because we're told that ABC is 15, then I can just go straight ahead and say this is 15 and this is 30. We've got basically all of the angles in the triangle sorted. I'm not going to label the other ones because they end up not being important. Let's now focus on the area. So for the area to be 24, it must be that the length of the sides of the square is root 24. Okay, so now I have a triangle, 90 degrees, with root 24 here. It's possible to work out the side lengths because these two are the same. In fact, there's a result that just says we need to divide through by root 2. So each of these will be root 12. And let me just show you this result. In fact, it's easier going the other way and saying this is x and this is x. Then the hypotenuse becomes x squared plus x squared, square rooted, which is the square root of 2x squared, which becomes root 2x. So going from an isosceles right angle triangle to the hypotenuse, you times by root 2, and going the other way, you divide by root 2. Just worth knowing that. It can speed things up. So where does that leave us? It leaves us that this here is root 12. And remember, I want to find out what CD is. So actually, I'm basically there. If I just now draw the triangle BCD in isolation, then I've got 30 degrees. I've got the length here, root 12, and I want to work out CD. I can use exact trig values. Tan 30 is going to equal opposite, which is CD divided by root 12. And tan 30 is actually 1 over root 3. That's one to just learn. And therefore CD becomes root 12 times 1 over root 3, or root 12 over root 3, which is going to become root 4, because you just do root of 12 divided by 3, which gives an answer of 2. Okay, that is a great question. I'm just going to, if you struggle with exact trig values, then I think I talk about this in other videos, but I'm just going to give you a method to help memorize them now. I mean, there's different ways. If you know the curves for sine, cos, and tan, that can really help. But I'm just going to give you like an algorithm, basically. This is purely an algorithm. It is possible to derive the values, by the way, and I would strongly suggest you look into that if you've not. But just to remember them, you can use this table method. So first of all, let's remember what values that we need to learn for 0, 30, 45, 60, and 90. With a bit of practice, you can write down this starting point. And now, for sine, we write down the numbers 0, 1, 2, 3, 4. We square root them. Again, just an algorithm, no maths behind this or anything, and divide through by 2. And that gets you your exact values for sine. So this one simplifies to 0, this one to a half, this one you can keep as root 2 over 2, or write as 1 over root 2. This one, root 3 over 2 is fine, and this one actually becomes 1. Because you just do the opposite, 4, 3, 2, 1, 0. Or you can just remember that actually it's the exact same values, but in reverse. So once you've simplified these, you can just write down 1, root 3 over 2, and so on. But okay, I'm doing it using this method because I think it helps with remembering tan as well. So now I get 1, I get a half, and I get 0. Okay, for tan, it starts out with the same numerator as sine did, 0, 1, 2, 3, 4. We square root them, but now we don't divide by 2. We actually go 4, 3, 2, 1, 0, and then find the square root of these. Actually, the reason for this is that tan is equal to sine over cos. That's a result with x's. Sorry, tan x is sine x over cos x. That was a result you can show using a unit circle. It's typically covered in A level. So you can figure out why this works if you understand this. It's an identity because it's always true. So it's not just an equation. Then this simplifies to 0. Oh, here we go. Tan 30 is 1 over root 3. After all that, that was the one I was interested in. This becomes 1, this becomes root 3, and this one's actually not defined. Tan is not defined at 90. Okay, just a little memory technique. At the end of the day, I think you can't do this question without being able to use the exact values of trig, so it's worth spending some time on them for these later sorts of questions. Well done.